Hi, everyone, and thanks for joining the October session of our Tech Connect Genius webinars with our Encompass partners. Today's topic is going to be wireless communication challenges and solutions for automated material handling systems. Before we get started, we're going to run through a couple of housekeeping items. If you're new to the INXPO platform, just a couple of tips and tricks on how to use it. So the audio will be streamed through your computer speakers, so you'll want to make sure that your volume is turned up and your speakers are turned on. The INXPO platform works best in Chrome or Firefox, so please make sure to use one of those browsers, especially if you start to experience any type of connectivity issues. Over on the right-hand side, you'll see we have the Q&A panel. Feel free to type in questions into this panel at any time during the presentation, and we've got a couple moderators standing by who will be keeping an eye on that. If you're having trouble connecting, again, you can refresh your browser or just make sure you're using Chrome or Firefox. And lastly, all of the panels that you see on your screen are adjustable. You can increase or decrease the panel size by pulling those corners out or clicking on the Maximize button on the upper right side of each panel. And next, just a couple of quick FAQs. Is this webinar recorded? Yes, all of our webinars are recorded. How do you access the recording? Well, you can use the same link that you used for the live version today. We'll also send you an email with information on how to access the recording in case you forget. And then lastly, where can you get a copy of the slides? You can navigate to the handouts panel on the upper right side of your screen, and you'll find a PDF of the slides as well as links to some other information that Keith is going to be covering today. And with that, I'd like to introduce Kim Porter. Kim, take it away.
Welcome again, everyone, to our Rockwell Automation Encompass Genius webinar this Wednesday. My name is Kim Porter. I'm with the Encompass program, and we have with us today domain experts from our global Encompass partner, ProSoft Technology. ProSoft has had a long-standing partnership with Rockwell for over 20 years, providing connectivity solutions that help solve customer networking challenges. And today's session, Wireless Solutions for Automated Guided Vehicle Applications, will be delivered by Keith Blodorn, Director of Project Management, specializing in IIoT and wireless communication. So without further ado, I'll pass things over to Keith. And if you happen to be attending Automation Fair, you can find him and his team in person on the show. Keith?
All right. Thanks a lot, Kim. Thanks, Catherine. My name is Keith Blodorn. I'm the product management director for ProSoft Technology. As Kim said, ProSoft is probably familiar to a lot of folks in the Rockwell world, Rockwell users out there. We've been an Encompass partner for many years, and I think a lot of people know us for the communication modules that we build for Rockwell PLC platforms. We also have a very strong product line in communication gateways, standalone gateways, and we've been involved in wireless communications in the industrial world for over 15 years as well. So we're really experts at solving industrial communication problems. Today I'm going to talk about some of the challenges that we see in a particular set of applications for wireless communication, and that's really around the automated material handling systems. When I talk about automated material handling, I'm really talking about a group of applications that include a few different specific solutions. A lot of folks are familiar with automated guided vehicles, AGVs, or laser guided vehicles. There's a few different terms for those. So I'll talk a little bit about those kind of systems. Some of the other systems that really apply in this case are things like Electrified Monorail systems, or EMS. EMS systems are pretty common in automotive and some other manufacturing areas. Skillet conveyors are something that's used a lot in automotive manufacturing, another kind of automated material handling system. automatic storage retrieval systems, very common in automated warehousing. So I'll talk a little bit about those systems. And then a particular use case that we find pretty interesting, or I find pretty interesting, are rubber-tired gantry cranes. These are used in shipping, in shipyards, and we've done some work solving some tough application problems for RTGs as well. So these are some of the topics that I'll cover. I'm going to talk a little bit about each one, about the application itself and how these technologies work, and then I'll get into the wireless aspect, how customers go about, how ProSoft customers go about addressing these problems, and how we help them build very robust systems. So first, let's look at the AGV. Automated guided vehicles are unmanned machines that roam about a factory or a warehouse and move material around from one place to another. The key part of the AGV is the wireless communication network that keeps each of the carts, the autonomous carts, connected to the overall communication system, to the central control system. They're very similar in terms of the communication aspect to these other material handling systems I mentioned, like EMS or automated storage retrieval and that kind of thing. What's very interesting about the automated guided vehicle market and automated material handling overall is the amount of growth that we see in these applications. The worldwide market for AGVs is growing at over 10% annually. When we look at other types of machinery, industrial machinery, that growth rate is nearly double the next fastest growing type of machinery. So AGVs and automated material handling in general, these applications are really gaining acceptance in a lot of different verticals. Automated material handling is very common in automotive. We see a lot in food and beverage, and in warehousing, distribution centers, and that kind of thing. But really, it's affecting. We're seeing automated material handling in all kinds of different manufacturing verticals. On average, an AGV system costs about $1 million, $1.25 million to install, and that's consisting on average of 4 to 5 vehicles, plus the infrastructure to put them in. But like anything, that average involves a tremendous amount of variation. So there are some systems that include, more than 100, maybe hundreds of autonomous vehicles, and others that are just a couple. So that just gives you a sense of what this automated material handling market looks like. Look specifically at AGVs. AGVs are available in a variety of different types, depending on what needs to be moved around. The most common are forklifts, essentially vehicles that look very much like a manned forklift, just without the place for the driver. They move around and move pallets and boxes just like a forklift would, except that they're automated. They don't require a driver. But as this technology has evolved and as these applications have evolved over time, AGVs have evolved into lots of different form factors. So there are specific pallet trucks, for example, assembly line vehicles, tuggers that will pull trailers with parts on them, all custom made for the kind of application that they serve, whatever manufacturing line that they're serving. Another key part of the automated guided vehicle is how the vehicle knows where it's going. The guidance systems can be laser guided. These have essentially rotating laser beacons on top of the vehicle, and these lasers will bounce off fixed reflectors at various points throughout the plant and use triangulation of the laser signal to know where they are. Magnetic guidance uses a wire in the floor or magnetic tape on the floor and follows that tape. Infrared is similar to the laser. It uses reflections off of known beacons. Natural guidance, which is somewhat new, allows the AGV to kind of determine through communication with other AGVs and sensors where it is on the floor. And we even see some vision-guided vehicles where a vision system is used to locate, keep the vehicle located throughout the plant. Most of these require some kind of a infrastructure, navigational infrastructure, either mounted in the floor or on the walls. And this actually becomes an important factor as we look at how to do wireless communications to these vehicles, whether or not we can use the installation that's already happening, or if we need to use something different. Another type of automated material handling system is the Electrified Monorail or overhead monorail system. Usually the acronym EMS applies to these. An EMS system, as the name implies, has a rail, typically overhead, that carriages attached to. The carriages themselves are individually driven, so they can move at different speeds. They can move parts to a particular assembly location and dwell at that location for some time, and then move to the next one. And because of this, they do need to communicate. They need to know from the master system what's happening so that they're coordinated, they don't run into each other. Each of these carriages will move parts around a factory. We see them a lot in automotive where the parts are very large and heavy. And they have multiple steps along the assembly process that they need to go through. So EMS are very common. Typically, the carriages are powered from a bus bar system, and we've seen in the past where customers will use that same bus bar for communications, except that has generated maintenance issues for a lot of customers, and we'll talk a little bit about that when we get into it. Another kind of system is called a skillet conveyor. These are very common in automotive. We see them in other industries as well, but mostly in automotive. And in a skillet conveyor, the entire platform moves along a path. Platform including the workpiece and in some cases even the workers. You can kind of see on the bottom left picture there, we've got an assembly worker working on a vehicle. And that platform, the entire platform, is moving through the plant. So you can not just move the workpiece, but the worker as well. In addition, skillets are sometimes height adjustable. So you can see in the picture the lift table that the vehicles are mounted on. This allows the work to adjust to the workpiece to adjust to the height of whatever needs to be done at that workstation. For automotive builders, this allows for a much more flexible manufacturing capability. Instead of having a line that produces the exact same car every time, one line can be used for multiple different vehicle platforms. And this is tremendously more efficient for the auto builder. And using this technology, they're able to adapt those lines to whatever process needs to be done. The automated storage and retrieval system is kind of automated material handling that's used in warehousing. Automated storage retrieval consists of shuttles that transport goods to and from racks. Typically, there is both horizontal and vertical motion. and sometimes multiple types of motion. For example, where you see the shuttle on the bottom right picture going between, going up and down a row of shelving, it will adjust up and down to the right level of shelving vertically. And then in some cases, we'll even have another satellite shuttle that will run out into one of the racks and maybe go, several racks in to retrieve parts. So these can be pretty intricate, pretty complicated systems to deploy. ASRS systems really speed logistics in a warehouse, and they allow denser warehouse layouts. If you don't need to plan for a fork truck to be able to drive down a row and turn sideways and get pallets out and back out and all of this, because you have an automated system to do that, you can space the warehouse shelves closer and closer together, and that saves capital cost for customers involved in warehousing. A lot of value, as I've kind of talked through these different types of systems, there's a tremendous amount of value associated with automating material handling for a lot of industrial customers. Just looking at the AGV compared to a manual fork truck, the ability to save a lot of money over the entire period of time where that system is deployed is pretty significant. Reducing labor costs is one big factor in why customers, why industrial manufacturers and warehouse owners choose automated vehicles. 72% of the total cost of ownership for a fork truck is just the labor to drive it. So just eliminating that cost makes a significant difference in an automated versus manual material handling. However, that's really just one factor. One of the big drivers that a lot of manufacturers cite for going to an automated solution is safety. There are hundreds of injuries from forklift operations every year reported in just the U.S. alone. That human error, that human factor, can cause problems. Automated systems have safety functions built into them. It's very important that a system has all these safety capabilities, so there are fewer injuries associated with automated vehicles. Operational efficiency can be improved with an automated system. That's lower work in process, faster turnaround of parts. When parts are delivered automatically to an assembly line, and the assembly line never has to stop because the station doesn't have the parts it needs, that improves the overall efficiency. Access to hostile environments is another big driver for using an automated system. When you have cold storage, for example, in food storage, refrigerated or freezer warehouses, having people driving fork trucks in there is kind of a tough environment to be working in. So an automated system eliminates the need for that. And finally, the automated systems really reduce product damage and inventory errors. One of our customers put in a fully automated warehousing system for shipping and storing wine, crates and crates of wine. And after 18 months, they did a physical inventory. They had 0 errors from what the automated system reported. It was the first time they'd ever had that in inventory. So automated material handling really has a tremendous amount of benefits for manufacturers and for folks in warehousing. When we look at deploying one of these systems, there's a lot of challenges in making it work in the industrial environment. This is where ProSoft really has all of our experience. And so we've been able to help a lot of customers deploy very successfully these systems that require operations in less than ideal conditions. These automated systems really need a reliable high-speed wireless communications. I mentioned that safety is a very important characteristic of the automated system, a very important function. So part of that safety is a communication system that maintains a very reliable link. Each of the sites where an automated system, automated material handling system is deployed has unique radio frequency characteristics. Every place is different. So there really isn't a simple, easy, cookie-cutter way to deploy wireless. You really need some expertise to understand how to deploy it properly. Enterprise products really fail to meet a lot of the specific needs of industrial applications. There's a tremendous amount of wireless Wi-Fi product on the market. Most of it is geared toward industrial or commercial use. Very little of it is geared toward industrial use, and yet we have very specific and very unique demands in the industrial space. And finally, a lot of the machine OEMs who are involved in automated guided vehicles or automated material handling really don't have time to become wireless experts. They don't really, these are folks who are expert at machinery, at making these AGVs run very efficiently. They're expert at the control system that keeps the AGVs doing what they need to do and coordinates them across the space. But wireless is sort of a secondary technology for them. So it's a real challenge to make these systems robust enough to work in the industrial and the warehousing world. We look a little bit closer, for example, at an automotive plant, and you just see some of these challenges and how they crop up. There's a tremendous amount of radio frequency noise, electromagnetic noise generated in an industrial plant that you don't typically see in an office building, for example. We've got robots and arc welders. We've got all kinds of things that can generate some noise in that factory that we need to know about and deal with. We have parts that are constantly moving around. The automotive manufacturers will refer to these things as doors or chassis or cars. In the RF world, we refer to them as reflectors because they tend to do a really good job of bouncing RF waves all over the place in ways that we don't necessarily detect when we first look at the RF environment. We have enclosed spaces that are unique to the industrial world. For example, this paint booth in the middle of an automotive plant. It's more difficult to get communication into these enclosed spaces, so we need ways to deal with that. Unusual work paths. Factories are, we like to think of a factory as a kind of a straight line. Parts come into one end, they get manufactured in a straight line and assembled, and out the other end goes the finished good. But in reality, the manufacturing lines change over time and become much more unusual. Control network timeouts. This is really a big deal that's very unique to the industrial world when we talk about the kind of network traffic that a wireless system in this application will carry. We see things like SIP safety being carried over these networks. SIP safety, in order to work, it needs to have a very continuous connection between all of the nodes. If any node loses its connection in a safety network for even a brief period of time, say 50 to 100 milliseconds, it will go to its safe mode. It will assume that it's lost communication, and typically in an automated material handling application, that means the carriage stops, the line stops, and that's not good. That doesn't help gain those efficiencies that these manufacturers are looking for in their applications. We have extreme conditions in these factories. These are not air-conditioned, comfy spaces. These can be very cold places, very hot places, depending on what's being done there. And finally, system maintenance. Maintenance on these systems is done by automation technologists, not by IT folks. So our tools really need to be geared for that. So let's talk about how ProSoft addresses these challenges through our solutions in the wireless space. The first one, and most important for our customers, is how we go about achieving maximum system reliability. This is critical. If the machine's not running, the manufacturer's not making money, and we're not achieving the goals of the automated system. So keeping the wireless system running reliably is critical. One of the things that we do that's really important in this goal is what we call ultra-fast roaming. In our RLX2 IHNF product, which is our wireless LAN radio, we've implemented a technology that allows the system to roam in a near lossless way. This is critical for those safety I/O systems where losing communication, even for 50 milliseconds or 100 milliseconds, will cause a machine to stop. Our roaming from client going from one access point to another occurs in under 10 milliseconds. And it does this in a way that we almost never lose a packet. So those safety I/O systems appear to have a continuous connection all the time. This makes the system much more reliable as we deploy it in these roaming AGV applications. Another really important part of an automated material handling system is project risk. These systems tend to be upgraded in a plant during an outage. For example, an automotive manufacturer may put in a new assembly line, or a shipping port may shut down one lane of its container storage to update the material handling system, but it needs to be done quickly and on schedule. So minimizing that project risk is critical for anyone involved in a material handling solution. At ProSoft, the most important thing that we bring to this project to address the risk is our application expertise. We have field application engineers throughout the U.S. and available around the world who work with OEMs in the material handling space, with integrators and with end users to really plan out the wireless system, make sure that we have the right solution given the unique RF environment that each one of these systems gets deployed in. That really helps give a lot more confidence to our partners and our customers that when they shut their machine down to do this project, it's going to come back up online when it's supposed to, and it's going to operate right. The other thing we do to really reduce the risk and make the system more reliable is we provide diagnostic information about the network, not just to the IT tools that are typically used in wireless installations, but also directly to the industrial control systems that we typically work with. We can take diagnostic information directly out of our wireless LAN radios and bring that information as tags directly into a Logix controller, or we can write that to a Modbus map over Modbus TCP. So this puts information about the network directly in front of the people who need to maintain that network and maintain that system, the control, the automation guys. So that helps to really keep the system running more reliably. Handling difficult paths and noisy environments, this is one of the challenges that's kind of top of mind for anyone doing these projects. Most customers in this space recognize that these applications are challenging, that they have a noisy environment and they need to deal with it, or their EMS system runs through the plant in a pretty unusual path, but they need to communicate to these carriages continuously over that entire path. At ProSoft, we've become experts at something called radiating cable solutions. And I'll talk about that here in a second. Radiating cable essentially allows us to place the RF signal directly along the path of the machine, wherever it goes in the plant. This is a great technology for automated material handling systems. We've used it extensively in this application, and it's something that we can help help improve your application by deploying this. Again, expertise is critical. Application expertise is critical in making radiating cable systems work, and that's something that our team is very experienced with, so we can help you deploy that kind of a system. Factories and warehouses are really difficult environments. This is not an office. So products have to be rated and designed to operate in those environments. Our radios are all industrial products. All of our products are. So that means that it operates in extended temperature ranges from -40 to +70 C. So whether you're operating, putting a system into a cold storage facility or a galvanizing line in a steel plant where the temperatures can range tremendously, our products are going to hold up in that environment. All of our products are hazardous location certified, Class 1 Division 2 in the UL world, or ATEX Zone 2 in the everywhere other than UL world. Of course, we have industrial power options. Our products take a 12 or 24 volt DC input, but they can also be powered over PoE for applications where that's available. Product is DIN rail mountable. That's important in the industrial world since a lot of equipment is mounted to a DIN rail. And it's shock and vibe tested in applications where the radio is going to be mounted in a carriage or on an AGV. It has to withstand the vibration and the shock that occurs in those moving applications, and our products are designed to do that. So let me talk about a couple of specific applications that we've done that will help kind of illustrate what these solutions look like in the real world. In this case, we had an automaker recently who wanted to reconfigure several of their plants. And what they were looking to do is to be able to build 3 different models on the same line. This was new for that automaker. And to do that, they really needed very configurable, flexible material handling systems, AGVs and skillets, AGVs to deliver parts to the line, different parts depending on the model they were building, and skillet lines that could adapt to the different models and the different sequence of production. They have all of these dynamics that I talked about, challenges in putting the RF system in place in an automotive plant with all the unusual paths and everything else. So they really needed a system that was going to work. This automaker went to several AGV OEMs looking for solutions, and the wireless LAN architecture was really a critical component for the automaker and the AGV to solve. One of the OEMs came to us looking for a system, and we suggested they use radiating cable, also called leaky feeder cable, along with our ultra-fast roaming wireless LAN capability. The AGV OEM conducted a proof of concept, built a portion of the system in their facility, and they did that to demonstrate the performance of the system. When they measured our radios. They looked at the performance of the radio, and in particular the roaming performance. They were unable to measure a roaming time for our system because of the zero packet loss roaming and very, very high speed roaming that we do, compared to other industrial solutions that would take 50 to 75 milliseconds to roam. So from a reliability standpoint, it was clear that our radios were going to perform for this application very well. Our solution involved our RLX2 wireless LAN radios using the ultra-fast roaming capability. The leaky feeder radiating cable solution had some specific benefits here. Leaky feeder provides a very consistent signal throughout the path of the skillet line, for example. Leaky feeder is able to follow the track of the AGVs throughout the plant. So that minimized the potential for blocked signals or anything like that that might have happened if we had tried to place access points with over-the-air antennas throughout the facility. Again, we've got those moving reflectors moving around the plant, and this reduces that risk. Our experience working with leaky feeder really reduced the risk of the project, and our access that we provided to our expert application engineers in this case was really a critical value pre-sale and post-sale for the OEM. We were able to help them through this project from beginning to end and make it very successful. The other application I wanted to talk about is a little bit different. I mentioned the RTG at the beginning of the presentation, and here's what this looks like. We did a project recently in one of the world's busiest container shipping ports in Asia. This is what the port looks like. You've got all these cranes here that offload up on the top right there, that offload ships, containers from the ships as they come in. And then those containers get stored in these long lines that you can kind of see in that top picture. Long rows of containers that are stacked 4, 5, 6 high and maybe 5 wide. And when the port needs to get containers in and out of that storage area, they use these gantry cranes, the picture in the middle there, that straddles that row, runs up and down that row, and picks the containers as they're needed. The idea of a rubber-tired gantry means that that gantry crane, instead of running on rails, is on its own tires, so it can actually move from one row to another when it's needed. It's much more flexible and efficient for operators. But historically, these cranes are run by an operator sitting in the crane itself, sitting in a pilot's seat up in the top of the crane, driving it up and down the row and pulling these parts. The problem with that is, number one, it's a terrible environment to work in. You're stuck in this crane all the way up in the top of this crane for hours at a time and really far away from any of the main buildings. Leads to human error, where the driver can occasionally, gets tired, can have a problem, and it's not efficient. You might have, in this case, they had 29 cranes in one section, and they don't need to use all 29 cranes all the time, but to get coverage of the entire yard, they needed all 29. So they'd have 29 drivers out there in the cranes for every shift, and they're probably using them 50% of the time. What this port did was they automated or made these remote control. And to do that, they had to bring all this information from the crane back into the system. This was the first time anyone had automated a port or made these remote control outside of Japan. So it was a very big project. Initially, they put in a different vendor's solution, also an industrial radio, but really didn't have a lot of the same design features for reliability as ours did. But they had also used radiating cable for this, which was the right thing to do. These RTGs, in order to be remote control, have to have cameras. In fact, they have 12 high-def cameras on every crane, so the operators can see what's going on. And the video quality in the original system was just very poor. Roaming didn't work very well. It took too long. That led to video choppiness, issues with the remote control joystick that drove the thing. So they were having a lot of shutdowns, and even for over a year, they just couldn't get it right. That led them to look at other solutions, other brand radios to try out. We did a proof of concept on site with the port using our wireless LAN radios with the existing radiating cable infrastructure. They tested the equipment on a test line with one RTG and a couple of access points for several weeks with zero issues. Did a bunch of measurements, all kinds of tests on our system, and determined that it really was superior. It really was meeting the need of the application. As a result, they deployed the ProSoft radios across the entire port. It was over 90 radios, 30 on the cranes, and another 60 access points. And they're using 2 parallel networks for redundancy, which makes it even more reliable. But ultimately, the ultra-fast roaming in our radios and the tuning that we did specifically for the radiating cable allows them to get their video streams seamlessly without any kind of choppiness or any of the issues that they were seeing before. And the control system maintains control of the RTG from the remote location without error. So those are two kind of illustrations of the problems that we see in a wide variety of material handling systems and the way we go about addressing them. So that's it. That's my presentation. I did want to leave some time. It looks like we have a good 10 or 15 minutes remaining for any questions that have come in. So I will ask Catherine or Kim if we've got some questions that that have come in yet, or anyone else to enter your questions now.
Yeah, thank you, Keith. So the first question that came in is from Alberto, and he said, is the RLX2 IHNF patched for WPA2 vulnerability?
Good question. We're evaluating I assume the crack or key replacement. I forget what the whole thing is. But there's a specific vulnerability in the WPA2 authentication protocol in wireless that's come up. We are doing a full evaluation of that. We have a patch that's going through the development process now that we expect to have fairly soon that addresses that. Most of our applications are not likely to be too impacted by it. Crack does require a direct connection, access to the wireless, which in most industrial applications is kind of rare. You don't have people getting into your facility that easily. And again, radiating cable applications in particular are particularly useful from a security standpoint because they limit the range of that wireless signal. But we are working on that, and we will have an update available posted on our website soon.
Excellent. Thanks, Keith. We did have another question come in, but we're waiting for some more information. The initial part of the question is this participant has a Compact Logix L33 ERM communicating with a scale checkware by sending ASCII over. How can I interface with a third modem, for example, a printer, to extract some data, not all of them, from the scale and send it to the printer to be printed?
Okay, that's a good question. ProSoft is actually quite good with ASCII communication. We have an ASCII module for Logix. I assume that's probably what he's using to get the information into the Logix. One of the things about our wireless infrastructure, our wireless radios support both Ethernet and serial communications. So, for example, if you're using the RLX2, you can take a serial RS-232, RS-485 network into that. The radio can do encapsulation on one end, send it where it's going, de-encapsulate it on the other end, and feed it serially into, for example, your ASCII module at your Compact Logix. So that is an application that you can likely do with our solutions. And I'd encourage you to contact your local ProSoft sales manager or your Rockwell distributor to get into more detail on that, so we can help you solve that.
Excellent, thank you. So another question just came in. Does ProSoft provide wireless accessories?
Yes, that's a good question. We do. So to make a wireless system work properly, it's very important to choose the right parts. When you see a picture of our radio, like I had in there, your antenna ports are just screw terminals, not screw terminals, but ports that you plug the antenna into. Choosing the right antenna is very important. We offer a variety of different antennas that fit specific applications. We also provide cables, lightning protectors if you have an antenna mounted externally outside, for example, and a variety of other accessories to meet the application needs. So, good question.
All right, and next question just came in. What are the main reasons to use radiating cables versus regular omni antennas, and when radiating cables are not a good solution?
Good. Radiating cable offers a lot of benefits when equipment follows a predetermined path. That's important. And you really need to keep, you have some interference concerns, things like that. You want to keep the wireless system somewhat contained. As I say, we've used it extensively on monorail systems where we follow the monorail, AGV systems where the AGVs follow a predefined path. Things like that, the RTG, which follows a distinct path. We've also used radiating cable to replace slip rings, for example, on rotating equipment. Those are all really good applications for radiating cable. When you don't follow a particular path, some AGVs are very autonomous. They guide themselves. They actually, radiating cable may not be a good solution in that case because the signal is really contained close to the cable itself. The other aspect of radiating to over-the-air antennas is cost. Radiating solutions tend to cost more than a over-the-air solution. So if you have a pretty open space, you don't have reflection issues, or you've got equipment in unknown locations, you just need to cover a wide area, then these or patch antennas for your access points are probably a better solution. Again, the best way to determine that is to contact the experts in our engineering group, and they can help you. They can help you with that.
Okay, Keith, here's another one. Do you have any watertight radios?
We do. Yeah, the RLX2 available in both an IP20 version, which is pretty standard, as well as an IP67 watertight version for applications outdoors or in areas where it's going to be exposed, to the environment. So yeah, we offer both.
Okay. What are the maximum lengths recommended for radiating cable?
The answer to that is the answer we give for a lot of wireless questions. It depends. It really depends on a few different factors in the application itself. First one being what data rates are required. And other one being, what is the connection? How will we be connecting to the clients? The clients are very closely coupled or close to the radios or to the radiating cable. We control that distance. We can go a longer length. And then as you go along the radiating cable, as it gets longer, your losses go up, which means your signal strength deteriorates. Typically, for example, in the RTC application that we did, we needed to have the highest data rate we could, which in this case was 150 megabits RF. We're not able to use MIMO in this application, so that limits the 802.11n transmit rate to 150 megabits. That's what we used. We were able to do that at radiating cable lengths of about 100 meters between axes. So that gives you kind of an idea. You can go longer than that for lower data rates, lower data rate applications. Or if your antenna for your client is going to be further away, further than, say, 8 or 10 inches from the radiating cable, that's another case where you would have to get further.
Okay, what can we offer for a client who's looking for wireless instrumentation solution in an EX or explosion-proof area?
So solutions for Class 1 Division 1 or ATEX Zone 1 really are very specific. We've worked with a few different companies that make systems for that and essentially package our radios into a Class 1 Div 1 or Zone 1 enclosure. But more than just the enclosure, there's also some engineering work that goes on to limit the energy that's available on the antenna itself. So help you find some of these outfits if you do have those applications with several of them, and ultimately that's how you go about doing it. Really is a application-specific solution, and we would point you to the OEMs who build that kind of stuff.
All right, and Kim, did we get all the questions that came in?
I am just scrolling through again. There might be one that might want to take offline, but I'll ask it and then you can decide. The presentation dealt with control point-to-point applications. Can this be utilized with control point to PC, especially with hazardous classified locations?
Sure. The radios themselves are standard 802.11 protocol, so they work with your PC. You can hook up to the RLX2 when it's configured as an access point. The RLX2 can be an access point. It can also be a client or a bridge. So same part number, just by duration, can do either one. But you can connect a PC to it. And if you have PCs that are in a hazardous location, like I said, you can we can help you work with, find a company to work with to package the RLX2 into an enclosure that works in that area, so it'll work.
I think that was it, Catherine, in the queue.
Right. Well, great. Thanks, everyone, for all your awesome questions. This was awesome to see the engagement with everyone. And thank you, Keith, for your time today and for presenting on the topic. I just want to remind everyone that we will send out an email with information on how to access this recording, as well as a link to the presentation, and then typed responses to all the Q&A as well, in case you missed it. But with that, we'll close out. Thanks again, everyone, and hope you have a great day.